All right, everyone, welcome to Chapter 4.1. Chapter 4 is all about studies of trigonometry, all right? So we're talking about triangles, angle relationships, and our 6 trigonometric functions. That's our sine function, cosine, tangent, cosecant, secant, and cotangent functions. So, as we said, exploring the world of trigonometry, measurement of triangles. An angle is formed by rotating a ray about its endpoint. You guys have all seen angles before, okay? Here I have an angle. And every single angle has an initial side and what is known as a terminal side. Initial side is where the angle starts. Our terminal side is where our angle finishes. And the corner of every angle is known as the vertex of that angle. Okay. Now, in many cases, we are going to be drawing these angles on our coordinate plane, right? And here we have what is known as an angle in standard position, right? We have our initial side on the positive x-axis. One thing to make note of is that positive angles are generated by counterclockwise rotation. This would be an example of a positive angle, whereas negative angles are generated by clockwise rotation. Notice again, in both of these cases, our initial side starts on the positive x-axis. Here we rotate in the clockwise direction for a negative angle. The measure of an angle is determined by the amount of rotation from the initial side to the terminal side. So measuring angles, we're talking about the amount of the rotation. And by now you guys are likely comfortable measuring angles in degrees. Here I have an angle measure of 120 degrees. Now, in calculus and in precalculus, this class, radians are going to be used more frequently. Calculus, radians is nearly exclusive. All right, radians are used to measure angles as there are many more applications with radians, and it is not an arbitrary measurement like degrees. Okay. If you ever wondered why there are 360 degrees in one complete revolution, well, that's because some person said that there was 360 degrees. It is completely arbitrary number. All right. The measure of a central angle, one whose vertex is the center of the circle, in the radians is given by the ratio of the arc length S to the radius r of the arc. So when we are getting radian angle measures, all we are doing is taking a ratio of S, our arc length, to our radius of the arc r. Arc length being this distance here, okay, the length of the arc that we sweep out, S, divided by r, the radius of the arc. And taking the ratio, S divided by r, will give us our angle measure in radians. Radian measure has no unit associated with it, as the units of S and r must be the same, and in this ratio causes them to cancel out. All right, so again, as I said, in this class, in calculus, all angle measures should be in radians unless you are working explicitly with triangles or if the directions specify to use degrees. So let's talk a little bit more about radian and degree measure. Okay, we just said the angle measure in radians is given by the ratio of the arc length to the radius of the arc. Because the circumference of a circle is 2 pi r, it follows that a central angle associated with one full revolution is going to be 2 pi. Think about that. If you were to take circumference, that's a measure of arc length of a full circle, 2 pi r, and divide it by r, well, the r's would cancel out, leaving you with 2 pi. All right, so 360 degrees, one complete revolution, that is going to be equal to 2 pi radians. The measure of that angle is 2 pi radians. One revolution equals 2 pi radians, or the equivalent of 360 degrees. Now, that means a half a revolution, well, that's going to be 1/2 times 2 pi radians is going to be pi, or 180 degrees. And a quarter of a revolution, well, that would be 1/4 times 2 pi. That would be pi over 2. 2/4 reduces into 1/2 pi radians, or 90 degrees. So we can use this conversion factor to help us change angles from degrees to radians or from radians to degrees. To convert an angle measure in degrees to radians, multiply the angle by the conversion factor pi radians over 180 degrees. For example, convert the following angles from degrees to radians. Here we have the angle 60 degrees. We know that pi radians is the equivalent of 180 degrees, so we can multiply 60 degrees times pi radians over 180 degrees. Now, anytime you guys use conversion factors, you can check to see if you are using conversion factors correctly by seeing whether or not the units cancel properly. Notice here, when I multiply, I end up with degrees in the numerator divided by degrees in the denominator. Those units for degrees cancel out, and we are left with radians in our numerator. So we multiply these together. This gives us 60 degrees divided by 180 degrees times pi radians. And we can reduce the fraction 60 divided by 180. That reduces into 1/3. This is 1/3 times pi, or pi over 3 radians. Let's also convert 135 degrees to radians. We would start with 135 degrees and multiply by pi radians over 180 degrees. Well, that gives us 135 degrees over 180 degrees times pi radians. 135 divided by 180. Now, if you're having some trouble reducing your fractions, don't be afraid to use your calculator to help, okay? Plug in 135 divided by 180 and select math frac after you hit enter. So 135 divided by 180, hit enter, then hit the math button and select frac. That will give you the fraction form of the 135 over 180, which is 3/4. So this is 3/4 times pi, or 3 pi over 4 radians. To convert angle measures in radians to degrees, we multiply the angle by the conversion factor 180 over pi radians. Notice that all we have done is we have flipped this conversion factor. So let's go through an example here. Convert the following angles from radians to degrees. Here we have pi over 6. Now, one thing to make note of is you know that an angle is given in radians if there is no degree symbol present. So no degree symbol here, we know it's radians. Versus over here on the left, we had degree symbols given with each one of those angles telling us it was degrees. So we have pi over 6 radians. We are going to multiply that by 180 degrees divided by pi radians. Again, check to see that your units cancel appropriately. Radians divided by radians, those are going to cancel and leave us with just degrees in our numerator. One thing to also notice is that this pi right here and this pi right here will also cancel out. That leaves us with 180 degrees divided by 6, and 180 degrees divided by 6 leaves us with 30 degrees for our final answer. Let's convert 3 pi over 2 radians to degrees now. Again, I start with 3 pi over 2, and I multiply by 180 degrees divided by pi radians. Notice the pi radians in both are going to cancel out. I have 3 times 180 divided by 2. 180 over 2 is 90. I can think of this as 3 times 90 degrees, which is going to give us 270 degrees. All right. And one thing to make note of is the quadrants at which our particular angles are going to lie in. So here I have drawn a complete circle, and as we said, angle measures, we're going to start them on the positive x-axis. Here we have 0 degrees, which is the equivalent of 0 radians. We have not traveled through any angle. 90 degrees, which is the equivalent of pi over 2 radians. 180 degrees, which is the equivalent of pi radians. That's what we use for our conversion factor. We have 270 degrees, which is 3 pi over 2 radians, and 360 degrees, which is the equivalent of 2 pi radians. So notice, get comfortable working in radians. In our first quadrant, the first quadrant will contain angle measures that are between 0 and pi over 2 radians. Our second quadrant will contain angles between pi over 2 and pi radians. Our third quadrant contains angles between pi and 3 pi over 2 radians, and our fourth quadrant is angles between 3 pi over 2 and 2 pi radians. One thing to make note of is that all of these radian measures, they can all be angle approximations, right? Mathematicians, we like using pi and keeping our values in terms of pi because it is an exact value. Pi over 2 is an exact number. However, there are times where it might be helpful to consider them as decimal approximations, as we'll see coming up. So if you were to take pi and divide it by 2, you would get approximately 1.57. This is the same thing as approximately 1.57 radians, 90 degrees. Same thing with pi. Pi is approximately 3.14 radians. These are all numerical values, so don't get intimidated by the value pi. 3 pi over 2 radians, approximately 4.71 radians, and 2 pi is approximately 6.28 radians. So let's see if we can't determine the quadrant in which each angle lies. Here we have the angle pi over 5 radians. Well, this is 1/5 of pi. Notice that 1/5 of pi would be between 0 and pi over 2, 0 and a half pi. Because 1/5 of pi is between 0 and a half pi, this angle would be in quadrant 1. The angle 9 pi over 8. Well, 9/8 of pi, that is slightly larger than 1 complete pi, 1 full pi, right? This is 1, if you were to write this as a mixed number, 1 and 1/8 pi. 9/8 of pi is between 1 pi and 3 pi over 2, that's 1 and a half pi. Therefore, this angle must be in quadrant 3. Negative pi over 3. All right, so negative angles. As we said, negative angles, again, we're going to start on the positive x-axis, but in this case, go in the clockwise direction. Now, we want to sweep through an angle that is equivalent to 1/3 of pi, just going clockwise. Well, I'd start here on the positive x-axis, sweep through 1/3 of pi. That leaves me with an angle here in the fourth quadrant. 2.25 radians. Well, again, in this case where we have a decimal value, it might be easier to think of our angle measures as decimal approximations. 2.25. Notice that 2.25 is in between 1.57, that's pi over 2, and 3.14 pi radians. That means that this angle, 2.25 radians, must be in quadrant 2. And negative 4.78. So this is, I'm going to sweep through an angle of 4.78 radians, but go in the negative direction. That would be clockwise. So again, this would be a half a pi in the negative direction, a full pi or 3.14 radians in the negative direction. This to 270, that would be negative 4.71 radians. Okay, again, going clockwise. And I need to go slightly beyond that to get to negative 4.78 radians. And that brings me into quadrant 1. All right, so there you have some relationships between your angles and trying to identify what quadrant some of your angles lie in.